Okay, for this video, we'll be going through manometer questions in the notes. So this is a G1 question. Okay, I think I went through in class already, but maybe some of you didn't really catch the concept or know how to do it. Okay, so before we start solving manometer questions, you need to be able to know this thing to apply this. Okay, basically draw a downward arrow on every liquid surface if there's a pressure acting on it. So if on top of the liquid it is vacuums, you don't need to draw a downward arrow. So in this case, I see that there's nitrogen gas here, so I will draw a downward arrow and then I'll put as Pn. Okay, just your own notation to show that it's the pressure due to nitrogen gas acting at that surface. Then I also see another liquid surface that has gas acting on it, and it is actually helium, okay, at pressure P. Since it is stated as pressure P, I'll just be using P to denote this pressure. Okay, next thing, we need to identify where do we have same liquid, same level, same pressure. Of course, there are a lot of places where we have the same liquid. In fact, they may even be at the same level. Okay, then therefore they'll be at the same pressure. But I also share in class that you need to choose wisely based on the dimensions that are given. So in this case, I will choose this place, right? Because later on I have my X and I'll have my Y to help me. So this is the place whereby we have same liquid, same level, same pressure, right? So once you have this, then you will know that the pressure over here on the left hand side is equal to the pressure on the right hand side. So pressure on the left hand side, I will put it as Pn, which is actually the pressure acting on the liquid surface by the nitrogen. Then it is actually equals to the right hand side's pressure, but right hand side's pressure is actually due to over here. So imagine you're here. So what is the pressure due to? It's actually due to pressure exerted by the helium, okay, exerted by the helium, plus the amount of mercury that is on top of this point. The amount of mercury that is on top of this point. The height of the mercury is actually X. So we are using pressure equals to rho GH, okay, in our calculation here. So our X is actually the vertical height. The G, it is the G on Earth, and the density, we see that they want us to show density of mercury to be rho. So there you have it. Therefore, if they want us to calculate and express the pressure of the nitrogen gas, Pn, I can put it as Pn equals to P due to helium. For G, I can substitute as 10, then X rho, and this is the solution. All right. So therefore, it's very important to apply these 2 points. Okay. This one I have done it in my previous video, but I'm just going to do it very quickly again to show you how do we go about solving. So over here it is vacuum, so I do not need to draw the arrow. Here it is acted upon by atmospheric pressure, and over here is air. So over here will be P air. Okay, so this is our first step. On every surface that is having a pressure exerted on it, I would have to draw arrow and then indicate what is the pressure due to. So once you are done with that, we can actually find where do we have same liquid, same level, and same pressure. Okay, so I want to find the pressure of the enclosed air. So possibly I can choose this level. Okay, and also this is sort of blocked by my arrow, but do you see that this height I can actually later calculate from here. All right, so we apply same liquid, same level, same pressure to this point, these 2 points. So on the left hand side, so this is left hand side, this is right hand side. Okay, So left hand side pressure will be equals to right hand side's pressure. Okay, so on the left hand side, the pressure is actually due to the amount of mercury above it. So how much is it? I see that this height is D. Okay, from here to here is D. Then from here to here is actually K, right? Therefore, this height of mercury is actually H minus K. Okay, so I will have maybe density of mercury. Rho G is 10, H is H minus K. Okay, then right hand side is actually simple. It's actually due to pressure of air. So there you have it. They want us to express the pressure of air in either using H, D, or K. So I just use H and K, and let's say if I know the density of mercury, I can solve this question, right? Okay, then G3, next question. Okay, so we actually have an open tube with one end in a mercury chamber that's connected to a gas supply. So this is the arrow that I need to draw, P gas. Okay, and this is another surface that has pressure acting on it. However, this is PATM. They want us to calculate and express the pressure of the gas, P gas, in meters of mercury. Okay, so where do we have same liquid, same level, same pressure? After we have draw in all the arrows that the pressure is exerting on the liquid surface, so I will choose this point. Okay, because my P gas is acted upon by this surface. So again, this is my left hand side, this is my right hand side. Okay, so my left hand side must be equals to right hand side's pressure because it is where we have the same liquid, same level, same pressure. So for the left hand side, I have PATM, okay, plus this amount of mercury on it. So I will do U, which is actually the height, G, which is 10, and the density. Okay, so this is my rho GH. On the right hand side is actually P gas. Okay, now they tell me that atmospheric pressure is H meters of mercury. That means it is H meters multiplied by 10 multiplied by density. So U 10 equals to P gas. Okay, so U can either be in meters or cm. Okay, so it depends on what U is. So if U is in cm, then I have to divide by 100 to get it to be SI unit. And of course, this rho is the density of mercury, which is 13600 kg per meter cube. Okay. Okay, I think we have one more question. Okay, it shows a manometer used to determine the density of liquid M. Okay, so let's do the first step first. It's actually PATM. And on this side is also PATM, right? Because they are both exposed to atmospheric pressure. Now, where do we have same liquid, same level, same pressure? It's actually at this level. Okay, same liquid, same level, same pressure. So this is step 1 that we need to do to indicate the pressure on the surface. And step 2 is identify where we have the same liquid, same level, same pressure. So let's do the left hand side. And the left hand side pressure must be equals to right hand side's pressure. The left hand side pressure is due to PATM plus this amount of water above it. So it's actually 6 cm. I need to convert it to meters, SI unit, multiplied by density of water, and multiplied by G. Okay. On the right hand side, it's actually PATM plus HCm worth of liquid M. Okay. Multiplied by 10, multiplied by density of M's density. Okay, multiplied by the density of M. So this is given, and they are in SI unit, so we don't need to do any conversion. You notice that both sides have PATM, so we can actually cancel them out, right? So let's do our calculation. So on the left hand side, it will be 600. On the right hand side, remember to convert your H to meters, yeah? On the right hand side, we have 75H. Okay, so therefore H will be H is actually 8 cm. Okay, so actually if you apply my both steps, step 1, which is draw the downward arrow to indicate what is the pressure acting on each liquid surface, and then applying step 2, which is to identify where do we have same liquid, same level, same pressure, it is very easy. Okay, one thing to take note that because density of liquid M is smaller than density of water, therefore we'll need a larger height of liquid M so as to balance the 6 cm worth of water, right? Because denser materials will sink while less dense material will float. Okay.